In this video, we'll explore 10 fascinating facts about the human brain, revealing its remarkable abilities that define our intelligence, emotions, and various senses. The human brain is a staggering marvel of nature. It is a vast neural network, with billions of neurons connected by trillions of synapses. This means that the potential number of neural connections in the human brain is far greater than the number of stars in the observable universe. To put this into perspective, imagine that each neuron is a galaxy, and each synapse is a star. This would mean that the human brain is like a cosmic web, with billions of galaxies connected by billions of stars. Of course, the brain is not just a jumble of neurons and synapses. It is a highly organized and structured system that allows us to perceive, think, feel, and interact with the world in incredibly sophisticated ways. The brain's complexity is what makes it possible for us to learn, adapt, and store memories. It is also what allows us to experience emotions such as love, joy, and sorrow. The brain is truly a universe of its own, and we are only beginning to understand its mysteries. But one thing is for sure. The brain is one of the most complex and enigmatic structures in the known universe. The brain is a complex organ that is responsible for a wide range of functions, including thinking, feeling, and moving. It is made up of many different regions, each of which has a specific role to play. These regions work together to allow us to perform complex tasks, such as learning, remembering, and controlling our emotions. The prefrontal cortex is located at the front of the brain and is responsible for a variety of functions, including decision-making, planning, problem-solving, and higher-level thinking. It is also involved in personality traits such as self-control, impulse control, and emotional regulation. The temporal lobe is located on the sides of the brain and is involved in auditory processing, memory, and language. The occipital lobe is located at the back of the brain and is responsible for processing visual information. The parietal lobe is located at the top of the brain and is involved in sensory information, spatial awareness, and body movement. The amygdala is located deep within the brain and is involved in emotions, particularly fear and aggression. The hippocampus is located in the temporal lobe and is important for forming new memories. The thalamus is located in the middle of the brain and relays sensory information to the cortex. It also plays a role in sleep, attention, and consciousness. The hypothalamus is located at the base of the brain, and it regulates a variety of bodily functions, including hunger, thirst, body temperature, and reproduction. The cerebellum is located at the back of the brain, and it coordinates motor movements and balance. The brainstem is located at the base of the brain, and it controls essential functions such as breathing, heart rate, and blood pressure. The limbic system is a collection of brain structures that are involved in emotion, memory, and motivation. It includes the amygdala, hippocampus, hypothalamus, and thalamus. The brain's processing speed, while not on par with the lightning-fast calculations of modern computers, possesses a unique and awe-inspiring quality that sets it apart. It excels in processing information holistically and creatively, a feat that surpasses the capabilities of any existing artificial intelligence. Unlike computers that rely on precise algorithms and rapid calculations, the brain's strength lies in its ability to recognize patterns, draw on past experiences, and adapt to novel situations with creativity and nuance. It doesn't rely solely on raw computational speed. Instead, it leverages its intricate neural networks to synthesize information, make connections between seemingly unrelated ideas, and generate innovative solutions to complex problems. This creative and holistic approach to processing information is at the heart of human intelligence, enabling us to excel in tasks that demand nuance, empathy, and a deep understanding of the world. While computers may outpace the brain in sheer computational speed, they still lag behind when it comes to the brain's capacity for comprehensive, inventive, and context-aware thinking. Have you ever wondered why your brain is so wrinkly? It's not just because you're getting old. The brain's intricate folding is actually a marvel of natural engineering. Imagine if your brain was flat like a pancake. It would be a lot smaller, and it wouldn't be able to hold as many neurons. So how does the brain get so much surface area in such a small space? It folds. The folds of the brain, called sulci and gyri, increase the surface area of the brain by up to 4 times. This allows the brain to pack more neurons into the skull, which enhances cognitive capacity. The folding of the brain also helps to reduce the distances that signals must travel. This is important because neurons communicate with each other by sending electrical signals. The shorter the distance that a signal has to travel, the faster it can be processed. The specific patterns of sulci and gyri are not random. They follow highly organized patterns that are unique to each individual. In addition to increasing surface area and reducing signal travel distance, the folding of the brain also provides some protective benefits. The folds cushion the brain against impacts and injuries. They also help to cool the brain, which is important because the brain generates a lot of heat. Have you ever smelled something and been instantly transported back in time? Maybe it was the smell of your grandmother's cooking, or the smell of the ocean on a summer day. These smells can evoke powerful emotions and memories, and they do so because of the close connection between the sense of smell and the brain. The olfactory bulb is a small structure at the base of the brain that is responsible for our sense of smell. It is also closely connected to the limbic system, a group of brain structures that are involved in emotions and memory. When we smell something, the olfactory bulb sends signals to the limbic system, which can trigger emotions such as happiness, sadness, or fear. The limbic system can also store memories that are associated with smells. This is why certain smells can be so evocative. The smell of a rose might remind you of your grandmother's garden, or the smell of coffee might remind you of your first job. These smells can trigger powerful emotions and memories because they are directly linked to the brain's emotional and memory centers. The next time you smell something that takes you back in time, take a moment to appreciate the power of smell. It is more than just a sensory function. It is a powerful connection between our emotions, memories, and the brain. Think of your brain as a power-hungry supercomputer. Despite representing only about 2% of an adult's body weight, the human brain consumes about 20% of the body's energy. So, what exactly is the brain doing that demands such a colossal amount of energy? Well, it's multitasking on an epic scale. Even when you're at rest, your brain is a hub of activity, managing vital functions like breathing, heartbeat, and regulating body temperature. Beyond these basics, it's also overseeing your thoughts, emotions, and all the intricate processes that make you who you are. Think of your brain as the control center for your entire being, working 24/7 to process information, solve problems, store memories, and create the rich tapestry of your consciousness. It's like your own internal computer that is continuously analyzing data, ensuring you can interact with the world, make decisions, and experience life to the fullest. Neuroplasticity, often referred to as the brain's plastic or malleable nature, is a captivating aspect of the human brain. It's like the brain's built-in superpower, allowing it to reorganize and adapt throughout life. This means that your brain isn't a fixed, unchanging entity. Instead, it's a dynamic and ever-evolving organ. One of the most remarkable aspects of neuroplasticity is its role in recovery after injury. If a part of your brain is damaged due to injury or illness, neighboring regions can step in and take over some of the lost functions. It's like a team of backup musicians ready to fill in if one member is unavailable, ensuring the show goes on. But neuroplasticity isn't just about recovery. It's also the key to learning and skill development. When you learn something new, whether it's playing a musical instrument, speaking a foreign language, or mastering a new sport, your brain physically changes. Neurons create new connections, strengthen existing ones, and sometimes even rewire pathways to accommodate the new skill or knowledge. This is why practice and repetition are so crucial in learning. The more you practice something, the stronger the connections between the neurons involved become. This makes it easier to do that thing in the future. Even as you age, your brain's ability to adapt and learn remains intact, although it may slow down somewhat. This fact challenges the notion that the brain's cognitive abilities inevitably decline with age. Instead, it suggests that you can continue to acquire new skills, knowledge, and adapt to changing circumstances throughout your life. The human brain, with its average weight of approximately 3 pounds, might seem modest in comparison to the rest of the body, but it is nothing short of extraordinary. Composed of a delicate balance of water, fat, proteins, and various molecules, the brain is the command center that orchestrates the complex symphony of bodily functions. It resides within the protective fortress of the skull, which not only shields it from harm, but also provides the ideal environment for its intricate operations. This relatively small organ holds the epicenter of your consciousness, generating thoughts, emotions, and memories, and stands as an enduring marvel of nature's engineering. The brain's tremendous blood flow is a testament to its unceasing activity and metabolic demands. With its intricate network of blood vessels, it commands a significant share of the body's resources, receiving about 20% of the total blood supply. This impressive circulation system ensures a constant and precise delivery of oxygen, glucose, and essential nutrients to every nook and cranny of the brain. Such a supply is vital for the brain's ceaseless cognitive functions, ensuring that it can process information, form thoughts, and execute complex tasks without interruption. Additionally, these blood vessels play a pivotal role in removing waste products, maintaining the brain's health, and regulating blood flow to accommodate the brain's varying energy requirements. The brain is the control center for pain perception, but it doesn't have pain receptors of its own. In other words, the brain itself cannot feel pain. This may seem counterintuitive, but it's actually a good thing. If the brain could feel pain, it would be constantly bombarded with signals from itself. This could lead to confusion and even damage to the brain. Instead, the brain relies on the pain receptors in the surrounding structures. When you experience headaches or other neurological symptoms, such as migraines or pressure-related discomfort, it's often these surrounding structures and membranes that are responsible for transmitting the sensation of pain to the brain. If you're experiencing pain in your head or neck, it's important to see a doctor to rule out any underlying problems. But it's also important to remember that the brain itself can't feel pain. So any pain you are feeling is likely coming from the surrounding structures. If you liked this video, please hit the like button and consider subscribing to our channel. See you in the next video.